Good morning. My name is Yash Sanjay Bahale. Me and my group are presenting a presentation on a topic is pole mounted substation. Subject name is Electrical Substation Practices. Guided by Professor S.M. HOD of Electrical Department. So, introduction. Nowadays, finding a suitable and convenient location for establishment of distribution transformer is one of the contests being faced by discoms. The issue is surf in carbon areas and discoms need to plan for suitable location for establishment of suitable capacity of DT substation. Considering the load in the area, load center, feasibility and further development and so forth, the distribution transformer might be mounted on single pole H-pole structure. Accordingly, the decision for establishment of pole-mounted DT substation is to be taken by DISCOMs dependent on the capacity of DT and availability of space. It is the most common of outdoor substation designed by DISCOMs conveniently at the load centers. Here are some pictures of pole-mounted substation. Need of pole-mounted substation: to receive power from primary distribution system and supply to consumer use, decreasing the voltage level from 11 kV to 400 volt for consumer use, provide facility for switching where power is turned on or off. It also provides safety to consumers when fault occurs in distribution line. Substation is required for providing supply street light and switching control of street light. It is interference between HV and LV distribution system. HV and LV distribution system in case of fault automatically reducing the reactive power by compensating reactive power with the help of tap changer transformer. Accessories which is there in pole mounted substation: first is pin type insulator, second is AB switch means air brake switch, third is lightning arrestor, fourth is circuit breaker, fifth is distribution transformer, then earthing, then digger fuse means dropout fuse, then stay wire, MV cable and LV cable. The figure shows the single line diagram of 11 kV 400 volt substation DP structure. The single line diagram contains the 11 kV distribution line, lightning arrestor, AB switches, dropout fuse, 11 kV 440 volt transformer, LTCB, etc. First, the 11 kV supply is coming from the state electricity board to the DP structure through cable wire metering unit at the AB switch, then dropout fuse, then pin type insulator, and then it goes to the transformer ST bushing. In this structure, the lightning arrestor are connected at the top. It is used to protect the substation equipment from lightning strokes. AB switch is used to isolate the supply from the system. If AB switch is open, then contacts are open and supply couldn't not come to the transformer. Hence, if fault occur at the consumer side, then by opening the AB switch, it can safely repair the fault. But before operating a fault, care should be taken that the line should be discharged properly. AB switch works as an isolator. After that, it contains dropout fuse. Then supply come to ST bushing of transformer. The transformer is 11 kV 400 volt 440 volt delta star connected, a step down transformer which step down the 11 kV to 440 volt to the main panel of college or industry. This main panel, the supply is distributed the main area through cables, MCB and other switches. Pole mounted substation. Such substations are used for supporting distribution transformer having the capacity up to 250 kV. Such types of transformer are the cheapest, simplest and smallest of distribution. All the equipment is the outdoor type and mounted on the supporting structure of high tension distribution line. Triple pole mechanical supported switch used for switching on and off the high tension transmission line. ST fuse is used for protecting of the high tension transmission line for controlling the low tension lines. Low tension switches along the fuses is equipped Lightning arresters are equipped over the high tension line for the protection of the transformer from the surges. Pole mounted substations are erected at two or more places. Pole mounted outdoor substation, the transformer having a capacity up to 125 kV are mounted on double pole structure, and the transformer having capacity between 125 to 250 kVA. Full pole structure with the suitable platform is used. Such types of substation are placed in very thickly populated location. Their maintenance cost is low, and by using a large number of the substation in a town, it is desirable to lay the distribution at the lower cost. But when the number of transformer is increasing, total kVA is increased, no load losses in increasing, and the cost per kVA increases.
Pin type insulator. A pin type insulator consists of a non-conductor material such as a porcelain, glass, plastic, polymer or wood that is formed into shape that will isolate a wire from a physical support or utility pole or other structure, provide a means to hold the insulator to the pin. By contrast to a string insulator, the pin insulator is directly connected to the supporting pole. The pin insulator is designed to secure the conductor to itself. Air brake switch. An air brake switch disconnects the vital part of the overhead line network, providing crucial points of isolation. Most overhead line network is designed so that when a fault occurs or maintenance work needs to be done, it is relatively simple by the means of symmetrical series switching operations to isolate the certain sections of overhead line. When this switching process is carried out by absolutely imperative that the air brake switch disconnector is reliable and effective. Lightning arrestor. A lightning arrestor is a device used for protection of damage from damaging effects of lightning. The general lightning arrestor needs high voltage terminal and ground terminal. The lightning arrestor are made of extreme high voltage spikes in incoming power lines and can be damaged from electrical appliances. If the protection fails or is absent, lightning that strikes in the electrical system presents thousands of kilowatts and may be harmful effect on the distribution lines, can also cause severe damage of transformer and other electrical devices. Lightning cells are made extreme high voltages spikes in incoming power lines can be very damaging to the electrical appliances. Distribution transformer. The distribution transformer is the important and biggest equipment of the electrical substation. The distribution transformer normally have the ratings of 500 kVA, although some national standards can describe up to 5000 kVA as distribution transformers. As they usually don't operate at full load, they are designed to have maximum efficiency at lower loads. Since distribution transformers are energized 24 hours a day, even though they don't carry any load at all, reducing the iron losses have an important role in their design. To have better efficiency, voltage regulations in this transformer should be kept to a minimum, and hence they are designed to have small leakage reactance. Dropout fuse. Dropout fuses are protective devices that protect the network and equipment from the current surges and overloads. An overcurrent will melt the fuse element in the carrier, disconnecting the line or equipment. They also provide network isolation points when manually operated with a hot stick. Distribution box. A distribution board is also known as panel or breaker panel. It is the component of an electricity supply system that divides an electrical power grid into subsidiary circuits while providing a protective fuse or circuit breaker for each circuit in common enclosure. This is the diagram of plate earthing. In this type of earthing, a plate either of copper or galvanized iron is buried into the ground at a depth of not less than 3 meters from ground level. The earth plate is embedded in alternative layer of coke and salts for minimum thickness of 15 centimeters. In LV and HV up to 11 kV kilovolt electrical installation, normally either a pipe or plate type earthing is provided as per IS 3043. The earth wire, copper wire for the copper plate earthing and GI wire for GI plate earthing is securely bolted to an electrical plate with the help of bolt and nut washer made of copper. For transformer body, 3 plate for transformer neutral, 2 plate for pole, 2 plate for LA, 1 plate separately grounded for EB switch, 2 plates for EB switch handle, 1 plate. Instrument transformers. These are the highest accuracy class electrical devices used to isolate or transform voltage levels. The most common usage of instrument transformer is to operate instruments or metering from high voltage to high current circuits, safely isolating secondary control circuitry from high voltage or currents. The primary winding of the transformer is connected to the high voltage or high current circuit, and the emitter or the relay is connected to the secondary circuit. Current transformer. Current transformer CT are a series of connected type of instrument transformer. They are designed to present negligible load to the supply after being measured and have an accurate current ratio and phase relationship to enable accuracy. Secondary connecting metering. This affords easy implementation on high voltage bushings or grid transformers and other devices by installing the secondary turn core inside high voltage bushing insulators and using pass-through conductor as a single turn primary. Standard secondary current ratings are 5 amperes or 1 amperes, compatible and with standard measuring instruments.
Voltage transformer or potential transformer. Voltage transformer is also called as potential transformer. These are parallel connected type of instrument transformers. They are designed to prevent negligible load to the supply being measured and have an accurate voltage ratio and phase relationship to enable accurate secondary connected metering. The PT is typically described by its voltage ratio from primary to secondary. A 600 120 PT will be provide an output voltage of 120 volts when 600 volts are impressed across its primary winding. Standard secondary voltage rating are 120 volts and 70 volts, compatible with standard measuring instruments. There are three primary types of potential transformer: electromagnetic, capacitor, and optical. The electromagnetic potential transformer is wired wound transformer. Second, the capacitor voltage transformer uses a capacitance potential divider and its use as higher voltages due to a lower cost than electromagnetic PT. An optical voltage transformer exploits the Faraday's effect, rotating polarized light in optical material. Routine, preventive, and breakdown maintenance. First, routine maintenance. Maintenance task that is done on plan and ongoing basis to identify and preventive problems before they result in equipment failure. Some common routine maintenance includes regular inspection or service work. This can be carried out on a time basis schedule. Preventive maintenance. The preventive maintenance is undertaken to ensure smooth and efficient working of a system. Equipment. Preventive maintenance is undertaken as per schedule before breakdown of a system or machine. Breakdown or corrective maintenance. Breakdown or corrective maintenance are undertaken after failure of an equipment. Such maintenance result is an outage of circuit and supply. In general, it consists of locating the trouble, repair, and recommendation. Routine maintenance. General inspection includes circuit connection, equipment's position, check mechanical operation, check tightness. Preventive maintenance. Disconnecting and earthing switch. Electrical test. First, insulation resistance test. Second, contact resistance test. Third, operating interlocking test. Check. B. Lighting arrestor. First, visual inspection. Support structure, grounding system and cleaning. Second, electrical test. Insulation resistance test, contact operation test, high polarity test. C. CT and PT. Insulation resistance test, turn ratio test by voltage meter, winding resistance test. D. Power cable, insulation resistance test. Preventive maintenance, circuit breaker. First, insulation resistance test. Second, contact resistance test. Third, operating timing test. Fourth, operation test. Transformer. Visual inspection, bushing, tank and associated device, load tap changer, oil level check, replace silica gel and cleaning. Electrical test, polarization index test. Third, turn ratio test by voltage method. Fourth, winding resistance test. Fifth, DGA, dissolved gas analyze test. G. Control and relay panel. Visual inspection, seal and body, setting relay recording. Second, relay feature, operation check. H. Battery and battery check, charger. First, visual inspection, seal and body cleaning. Second, electrical test, insulation resistant test, charge operating system function check, voltage battery cell check. This is the layout of pole mounted substation. The SLD of 11 kV kilovolt substation. Advantages of outdoor substation. First, all the equipment in the outdoor substation is within view and therefore fault location is easier. The expansion of installation is easier in the outdoor substation. The time required in the construction of such substations is lesser. The smaller amount of building material like steel, concrete is required. The construction work required is comparatively less and the cost of switchgear installation is very low. Repairing work is easy and proper space is provided between the apparatus so that the fault occur at one point will not be carried over to another point. Disadvantage of outdoor substation. More space is required for the outdoor substation. Protection devices are required to be installed for the protection against lighting surges. The length of control cables which increase the cost of substation. Equipment designed for outdoor substation are more costly because outdoor door substation equipment require additional protection from the dirt and dust. So thank you for watching.